This is AQA Chemistry. It is the GCSE Dual Award component, although this all is also included within the Triple Award. In this section, we're going to take a look at how we can represent atoms, molecules and compounds, and we're also going to look at chromatography. So I'm going to recommend you pause on each activity, try it for yourself, and then when you're reviewing, you get to see what's gone well and what might need some development. So here is the first task, pause away. And on here, what we're trying to do is recognise what these diagrams are telling us. So we have got in A, for example, 4 individual white circles. They're all identical to each other. So because they're not combined with anything else, because they're entirely on their own, we know that they are atoms. And if it's an atom, there can only be one type of atom in there. They're all the same. So because they're all one type of atom, that means that we are looking in A at atoms of an element. And you can see the keywords highlighted there. And it's really important that you are confident in using the correct keywords in the correct place. So let's take a look at B. Well, B has got more than one type of atom and it's chemically combined. So that means it's actually a molecule because there's more than one atom chemically combined. And because it's more than one type of atom, that means it's a molecule of a compound. In C, once again, we have got more than one atom chemically combined. We've got a black and a white circle, so it's a molecule. And because there are different types of atom chemically combined, that means that once again, this is a molecule of a compound. On to part D now, and we've got here 4 circles, but look really carefully. We've got 2 white and we've got 2 grey. So they're not chemically combined. That tells us that we're dealing with a mixture. Now we are dealing with a mixture of, they're all individual atoms. There are no molecules in there. So it's a mixture of atoms. And because they're atoms, they are definitely, we have the white is one element, the grey is another element, so it's a mixture of atoms of elements. Then we move on to E, where we have got black circles, and it's the same black circles in there. Now there's more than one atom chemically combined, so it's a molecule. But it's not a molecule of a compound this time because it's all the same type of atom. So this time we're dealing with a molecule of an element. This is a diatomic molecule. You will see this with hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Finally, we're going to go on to F, where we've actually got 3 entirely different molecules. So we have got a mixture. They're not chemically combined. Within those molecules, well, they are molecules because there's more than one atom, and they are different molecules of different compounds. So it's a mixture of molecules of compounds. Okay, we're going to move on and do a little bit more work here on different elements and how they exist. So 5 gases named in the passage. Identify them and state whether they are elements or compounds. Pause and try all of these and then review your answers. Well, I've gone through and I've highlighted. We've got nitrogen, N2, oxygen, O2, argon, AR, carbon dioxide, CO2, and we've also got water. Now, we conventionally think of water as a liquid, but it does state very clearly here that it's water vapour. So it is a gas. So they're the 5. And we then wanted, for number 3, which of the gases in the air exists as single atoms? Well, the only one, we've got 3 elements, nitrogen, oxygen and argon. Argon is the only one with individual atoms. And you can see I've drawn out 6 atoms of argon here. They're all identical, they're white circles, they're spread out, they're not chemically combined. That's what we were looking for. For number 4, name a gas in the air which is an element made from molecules containing 2 atoms. Draw a diagram to show how these might be represented. Now we can see the both of them here. They're in green, nitrogen and oxygen. And the way that we are going to draw that is by doing pairs of atoms chemically combined. And I've put 4. That could be N2 or it could be O2 because I haven't got a key to say what the colour represents. That's what we were looking for. And finally, for number 5, a gas in the air, which is a chemical compound. We have 2 to choose from. That's carbon dioxide or water. Now, in each of those, you have 1 central atom with 2 atoms connected to it. So I've drawn carbon dioxide here. My carbon is the black circle with my 2 white oxygens connected to it. And I've drawn 3 of those. And again, this is a gas, so those compounds are spread out through the space. We're going to finish off by looking at chromatography. And it's difficult to actually do this because you're not doing the practical. And the question about how many different dyes were in each food colouring, that's something that I'm going to suggest you pick up with past paper questions, which will be added to the appropriate playlist for this topic as I move forward. But we are going to be able to answer some of the general questions that help explain chromatography. So have a think about these and then review your answers. So the first one, why was the line drawn in pencil? Well, we know that we often use chromatography to separate inks. If I use a pen, that is ink. The ink will dissolve in water. And so we don't want the ink line to become a part of the chromatogram. We're not going to be able to have valid results based on what we're actually investigating. Why did we label the spots? This is a purely practical thing. We want to know, after our dots have spread out up the page, what it is that's separated. We're just making it as clear as possible. We're adding that clarity to make sure we know what it is that we are investigating. For number 4, why is the chromatography paper hung with the bottom in the water? You can see that just here. We have a water line, we have the paper dipping into that water. Well, the water soaks into the paper and it rises up. It's as it rises up that the ink from the spots we've added dissolves into that water and gets carried up the paper. So we need to do that so the paper will soak up the water and it will dissolve the ink. Number 5, why must the water level in the beaker be below the spots? Again, you can see that here the spots are way above the water line. If it was below, the ink would just go straight into the water in the bottom and we wouldn't get that separation on the paper. And finally, number 6, why do we want to wait until the water's moved almost up to the top of the paper before we take it out to dry? And the reason for this is that we want to get the maximum opportunity of separating out the ink that we're investigating. If those spots get further apart, if the colours separate more clearly, we can be far more confident in what we're seeing than if we stopped a centimetre up and it was still all very close together. Okay, that takes us to the end of this video. Thank you for listening and goodbye.